There is a widespread assumption across almost every professional field right now that generative AI is basically a highly advanced search engine, but it doesn't retrieve stored information. These systems do not possess grounded semantics, and they have absolutely no internal mechanism to understand verifiable truth. Instead, what you are looking at is a probability engine. It optimizes entirely for linguistic fluency, stitching words based on statistical patterns so the output sounds convincing, whether it is factually correct or not. Because answers sound so articulate, highly trained experts in law, medicine, and finance take these outputs at face value. Treating a system designed for statistical probability as if it were a deterministic fact retrieval machine introduces invisible, systemic vulnerabilities into professional workflows, threatening the foundation of human expertise. Discussions about AI often center on the risk of job replacement, but a more immediate shift is occurring in how we process information, a steady erosion of human cognitive reflexes. Cognitive psychologists refer to this as a decline in epistemic vigilance. Epistemic vigilance is our built-in cognitive defense mechanism, the critical ability to evaluate the source of information, spot logical inconsistencies, and independently verify claims. Expertise is the intuitive grasp of patterns and exceptions that you only build through the mental friction of solving difficult problems. When you bypass that struggle and let an algorithm deliver the answer, that tacit knowledge gradually fades. This sets the stage for the knowledge paradox. When we outsource the mental struggle of understanding to an algorithm, we risk losing the analytical depth required to manage the very tools we are using. To understand exactly why generative models confidently invent information, a phenomenon known as hallucination, we have to look at the underlying mathematics. The process begins the moment you submit a prompt, but the AI doesn't read your sentence. It performs a step called tokenization. This image shows input text fragmented into color-coded tokens. The system breaks your request down, converting human language into a sequence of numbers. Each token is then mapped as a vector in a high-dimensional space, mathematically building a complex web of statistical relationships. This diagram outlines the generative AI cycle. The bottom wedge, the attention mechanism, calculates token relevance to track context. Moving left, it generates a probability distribution of the next word's likelihood. Finally, it selects text based purely on statistical weight, not verified facts. Because this cycle is purely mathematical, writing a longer, more detailed prompt does not actually increase the factual accuracy of the output. Excessive prompt length merely forces the model to run this probabilistic selection process over and over again, increasing the chances of irrelevant or redundant text. Furthermore, overly long prompts risk exceeding the model's context window. A context window is the strict limit on how much past information the AI can hold in its working memory at any given time. Once you push past that limit, the AI starts dropping earlier details, which leads directly to logical contradictions and a loss of coherence. Because the AI is simply generating text token by token based on statistical math rather than semantic meaning, hallucinations are a structural inevitability. This is illustrated by the Chinese room argument. If you lock someone in a room with a rulebook detailing how to match incoming and outgoing symbols, they can produce perfect, fluent responses without actually understanding a single word of the language. Generative AI is that room. Because it lacks any internal verification mechanism to check facts against reality, its entire output depends heavily on the frequency of patterns in its training data. This reliance creates the herd effect. If an incorrect statement appears frequently, that widely repeated falsehood will statistically overwhelm factual truth. The math dictates the AI must assign a higher probability to that amplified bias, treating volume as a proxy for accuracy. When faced with an obscure query or contradictory data, the system is designed to always select a probable, fluent-sounding answer, rather than admitting it simply doesn't know. Without external fact-checking and grounding, generative AI acts as a massive statistical amplifier for popular misconceptions, rather than a source of objective truth. In the traditional workflow, problem formulation moves into deep synthesis, resulting in a decision. Inserting AI to handle synthesis creates an instant shortcut from formulation straight to decision. With AI handling the heavy lifting, human synthesis capacity weakens through disuse, causing automation complacency. Consider a financial analyst relying on AI to review balance sheets. Over time, because they stop manually interrogating anomalies, they begin to miss complex, novel fraud patterns that don't fit historical data. Or a lawyer using an AI tool for rapid contract review. The system pulls standard clauses, but the lawyer misses subtle, context-specific loopholes requiring human judgment and understanding of client intent. Eventually, professionals lose the ability to catch AI's errors. They assume the output is correct, simply because the language is perfectly formatted and highly fluent. Warning tone. Outsourcing the cognitive struggle to an algorithm transforms active, rigorous problem solvers into passive, vulnerable recipients of unverified probabilities. The solution to this paradox requires structurally demoting AI. We have to stop treating it as an autonomous oracle and start treating it as a strictly supervised copilot. A hybrid intelligence architecture enforces a multi-layered verification loop. It requires human input, uses AI for a structural scaffold, then demands human evaluation against primary sources. Key to this is Socratic prompting. Generate your hypothesis first, then use AI to stress test arguments. To prevent skill degradation, professional environments must also implement rotational AI dependence. This means intentionally stepping away from the algorithm and periodically executing key analytical tasks entirely manually. It is a necessary exercise to preserve your tacit knowledge in professional intuition. Building financial valuation models from scratch, conducting a manual literature review, doing the raw work ensures your baseline intuition remains sharp. By treating AI as a scaffold rather than a crutch, professionals can extract all the computational efficiency of the tool without sacrificing their cognitive edge. Ultimately, there is one critical capability that AI cannot automate: multidisciplinary thinking. AI models are compartmentalized. They overfit to specific domains and lack cross-domain cognitive flexibility. True human value lies in bridging those silos, synthesizing insights across disparate fields, like connecting behavioral psychology with macroeconomic data, catches edge cases a specialized algorithm misses. This cross-disciplinary knowledge is what allows a human professional to look at an AI-generated output and immediately recognize when a mathematically sound decision lacks broader societal, regulatory, or economic perspective. Holding the steering wheel requires more than just oversight. It demands the professional retain final ethical and logical responsibility for every result. In an environment dominated by algorithms, human value rests on intellectual agility. High-value professionals use these tools to amplify their own judgment, ensuring they remain the final architects of the decision.